Alright, this video covers our notes over Pythagorean theorem. First of all, Pythagorean theorem, you need to know, can only be used on right triangles. No other triangle will work. It must be a right triangle. Okay? The formula that we use for Pythagorean theorem is real simple. A squared plus b squared equals c squared. And A, B, and C all stand for a particular side of the triangle. So if you're looking at a right triangle, remember your right angle is going to be noted with a little box most of the time. Okay, so my suggestion is to always locate that right angle, because directly across from the right angle is always going to be C. Okay, and C has a special name. We call C the hypotenuse. The hypotenuse. Okay, so C is the hypotenuse. He is directly across from the right angle, and it is also important to note that C is always going to be the longest side of the triangle. Whenever you're looking for C, C is directly across from a right angle, and he's always going to be the longest side. Okay, then the other two sides of the triangle are A and B. It does not matter. This side could be A, this side could be B, or this side could be A, this side can be B. Okay? So we'll label A over here, and A is called the leg of a triangle, and then B on the other side is also called the leg of a triangle. Okay? So we have two legs, just like you, and then the hypotenuse across from that right angle. Okay? So let's take a look at this picture here. So what the Pythagorean theorem tells us is that the area of a square plus the area of a square is going to be equal to the area of the largest square. So if you look how these three squares are arranged, if you look right in the middle here, they have formed that right triangle. Okay, here's my right angle. So then directly across, this would be C, my longest side, and then we can make the left side A and the bottom B. Okay, so let's investigate this a little farther. Okay, if we look at square A, he is 4 units long. Okay, square B is 3 units long, and square C is 5 units long. Okay, so going back to this idea of Pythagorean theorem, the area of this square plus the area of this square should make the total area for this guy. Okay? Remember, area of a square is length times width. So 4 times 4, this is going to give us an area of 16 for this one. Okay? 3 times 3 would give us an area of 9. And 5 times 5 would give us an area of 25. Okay, so let's look at that in terms of the Pythagorean theorem. A squared plus b squared equals c squared. So we said square A was 4 units long, and we did length times width, which was 4 times 4, and that's what 4 squared means. 4 squared means 4 times 4. Okay, plus the area of this square, we did length times width, that was 3 times 3. 3 squared means 3 times 3. Should be equal to this one, 5 times 5 is 5 squared. Okay, so 16 plus 9 should equal 25, and 16 plus 9 does in fact make 25. So this proves that this is a right triangle. Okay, that's what the Pythagorean theorem does. So let's look here. 1, 2, 3, and 4 are wanting to know simply, is this a right triangle? So we're going to use Pythagorean theorem, a squared plus b squared equals c squared, to check to see if it's a right triangle. Okay, so remember what we said here. The hypotenuse is always going to be the longest side of the triangle. If I look here, I don't see a right angle marked anywhere, and I cannot assume, even though it looks like it, we cannot assume that that's a right angle. But I can look at my sides, 9, 40, and 41, and I see 41 is the longest side, so that has to be C. That has to be my hypotenuse. Okay? And we'll use 40 as A and 9 as B. Or we could do A as 9 and B as 40. It does not matter. Okay? So let's go to our formula. A squared plus b squared equals c squared. And now I'm going to substitute in my numbers. A we're calling 40, so this would be 40 squared, plus b squared would be 9 squared, is going to be equal to 41 squared. Okay, and now we just go to Desmos. So we're going to put in 40 squared plus 9 squared. 40 squared plus 9 squared. Whoops. Just kidding. Hold on. 40 squared plus 9 squared. Wow. Is 1,681. So this gives us 1,681. Okay, and we want to know if that's going to equal 41 squared. So I'm going to go back to Desmos and put in 41, good grief, 41 squared is also 1,681. So since we have a match right here, this is a right triangle. Okay, and we proved it using Pythagorean theorem. So let's look at number 2. We have 10, 8, and 14. So I know that 14 has to be my hypotenuse. It has to be C. Okay, we'll use A as 10 and B as 8. So we're going to go to the Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to put in 10 squared plus 8 squared equals 14 squared. Then I'm going to put this in Desmos. 10 squared plus 8 squared. And that gives me 164. And I want to know if that is equal to 14 squared, which is 169. Excuse me, 196. So we can see here, this is not going to be a right triangle because we did not get the same number both times. Okay? 3 and 4 are just the same. All I did was take the picture away. So this tells me I have a triangle with a side length of 12, 16, and 25. Looking at this list of numbers, I should be able to identify that 25 is going to be the hypotenuse because he is the longest side. Okay? And then we can just go in order. 12 can be A, 16 can be B. Okay, so let's go to our formula. A squared plus B squared equals C squared. We'll have 12 squared plus 16 squared equals 25 squared. We're going to put that in Desmos. 12 squared plus 16 squared should give you 400. And 25 squared gives you 625. So you can see that this is not going to be a right triangle. It is not going to work. Okay? Number 4, we have a triangle with side lengths of 12, 35, and 37. So 37 is going to be our hypotenuse. And we will use 12 for A and 35 for B. Okay? So let's go to our Pythagorean theorem. A squared plus B squared equals C squared. And we're going to substitute in our numbers. Okay, so we're going to have 12 squared plus 35 squared should equal 37 squared if it's going to make a right triangle. Okay, so 12 squared plus 35 squared gives us 1,000. Squared plus 35 squared. This is not working out for me today, guys. I am sorry. 1,369. Okay, and if we put 37 squared into Desmos, 37 squared, it also gives us 1,369. So this is a right triangle. Okay? Now, unfortunately, that's not all you're going to have to be able to do with Pythagorean theorem. So on the front, we were given A, B, and C, and we were just verifying if it was a right triangle. Here, on the back side, you're going to be asked to find a missing side. Okay, so this one, 1 and 2, we're looking for the hypotenuse, remember, which is C. Okay, so if we look at number 1, here is my right angle. Directly across from that right angle is going to be C, which makes sense because that's the side that's missing. Okay, so we can use A as 4 and B as 9. And we're still going to go to our formula, A squared plus B squared equals C squared. So we will have 4 squared plus 9 squared, but this time we don't know C, so I'm going to leave C squared alone in my formula. Okay, now, that can go to Desmos. 4 squared plus 9 squared makes 97, okay, is equal to C squared. Now, our last step here, just like we were solving equations, we were always doing the opposite. I don't need C squared, I just need C. Okay, so the opposite of squaring a number is taking the square root of a number. So if C squared is 97, then C by itself has to equal the square root of 97. Okay, and then we can put that into Desmos right quick. The square root of 97 is this big old long crazy number, but we're just going to go 2 places behind the decimal, so 9.84. C would be equal to 9.84. Okay, let's take a look at number 2. Here's my right angle. So directly across from it is my hypotenuse. So we can use the other 2 sides as A and B. Formula first, A squared plus B squared equals C squared. I'm going to fill in A and B. So 7 squared plus 7 squared. And again, we don't know C, so we're going to leave him alone. Okay, 7 squared plus 7 squared is 98. But remember, we don't want C squared, we just want C. So if we want C, we're going to have to do the square root of 98. So Desmos square root of 98. Again, we're just going to go 2 decimal places. So 9.89. C equals 9.89. All right, now, you're not always going to be looking for the hypotenuse, okay? If we look at these 2 down here, my right angle is here. This time, I know my hypotenuse. C is going to be 17. But we don't know A, okay? So let's look at how that works. If we go to our formula, A squared plus B squared equals C squared. This time we don't know A, so I'm going to leave A squared alone. This is going to become 8 squared, and this will be 17 squared. Okay? Now, in Desmos, you cannot put A squared plus 8 squared. It's not going to give you anything. Okay? We're just going to put in 8 squared and get a number, and 17 squared and get a number. Okay? So that this becomes A squared plus 64 is equal to 289. Okay, now, we just got done solving equations. Okay, if I need A squared to be by itself, I have to do the opposite of plus 64. So I'm going to subtract 64 on both sides. That leaves me with A squared and 225. Okay, and just like we were doing up here, if C squared was 97, to get C, we had to do the square root. So down here, if A squared is 225, if we just want A, we want the square root of 225, which is going to give you 15. Okay, you can try this example here and bring it to me to check.